All right. Well, thank you so much for joining us, Whit. So today we're joined by Whit Walters, who's Field CTO at GigaOm. Now, Whit, you have a lot of experience both on the business and the technical side. So I think I'd like to start by just learning a little bit more about you and your experience.
Good morning, Bonnie. So I'm Whit Walters, one of the field CTOs for GigaOm. My background is in databases. I kind of started with data products back in the 90s, kind of before the last, kind of that first tech boom coming out of the internet age. I've been CTO of a couple of startups out here in Boulder and have been working with vector databases. I've been doing quite a lot in both kind of the data, the analytics, and the AI field. So it's a great conversation to be able to have with Vesta and vector databases.
Yeah, I mean, I imagine this is a great time to be in this space right now because it's kind of blowing up quite a bit. And so many vendors out there now really, incorporating vector databases, also just vector database standalones. And one of the things that GigaOm does is they put out a Sonar report, which Vespa was recently a leader on. And I'd like to know a little bit more about how this report comes together. So can you share more about, how you build it? How should we be looking at it? How should we be reading this?
Sure. So let's talk. I'm going to share my screen a little bit. We're going to talk about how we build the sonar. What do they look like? Where do they come from? And kind of how do we even put these things together? So GigaOM does what we call sonar and radars. It's a way for us to take a lens and look at a specific field and analyze it and start to put things together. When we put together a sonar, it's half of a radar. But what it means is we see an emerging technology field and we start to evaluate it. And we start to say, okay, these are the technology parts of a vector database set. How are they different? How are they the same? And then we start to rank all the vendors together. When we start to do that, we look at things like innovation. We're also looking at platform play and feature plays. A platform play is a little bit broader approach, and then a feature play is kind of more of a targeted focus on certain things, either kind of like a deep set of like industries, particular verticals, or they're looking at specific features and functionalities inside the broader piece. So looking at that, then we also start to say, who are the leaders and who are the challengers in here? So the closer you are to the center, the higher you score across all of our decision criteria. What that means is, as you're getting closer to that bullseye in the center, it's a little bit more of, hey, this is the ones that score higher. So when we talk about the leaders and the challengers, as you can see, Vespa is very close to the bullseye in the center, and we positioned you as a leader. We also see Vespa a little bit more as a platform play. And again, it's more looking at platforms in terms of robust set of features across lots and lots of things. And as you can also see, Vespa is a fast mover, which means you're moving a little bit faster or a lot faster and innovating more quickly than the rest of the field. Those fast movers really kind of indicate you're leading the industries in terms of how quickly are you innovating? What are you doing? What are the things that you're innovating on? And where quickly do we go? And so if you want to use this in terms of kind of figuring out where Vespa sits, we don't just say you're a leader, but we also, if you look at the sonar, and we'll talk a little bit about why today, we'll take that sonar and say, we write a vendor capsule and we explain in detail about why we think Vespa's a leader. We position you against the others and you can see you score very well. And that's how we start to build out a sonar. And again, it's just looking at an industry through a lens, and we rank all of the vendors and say, these are the ones that we think are, really leading the pack and doing well with that. So when I talk about a vector, what that really means is if I'm building out an AI system, like a machine learning or an AI system, I take all that information and AI, even though we can talk to language models, the language models do not understand language. Now, that sounds really strange, but like if I give it a word like cat or dog, those words get turned into numbers like 5 or 2,758. So think about it like we just take those words and turn them into dictionary pieces. Now, this is really where the brilliance of a vector database comes in, because we take those words and then we can store them in such a way, we embed them and we put them in there and we put them in a database, and now we can search for those words. But these are traditional databases that did other things, and now they're trying to be jack of all trades,
Hmm.
and they're trying to put things in. That's why on the radar, you see them not scoring as well as some of the purpose-built vector databases that do it very well.
Right, that makes sense. And I think something that might be surprising for some people to learn is that Vespa, as a startup, spun off from Yahoo a couple of years ago, but really has been working with vectors since 2014. And I think that's what's really allowed the rapid kind of evolution of the product today, allowing us to innovate quickly. Speaking of the different types of searches, Vespa supports lexical, vector, and hybrid search methods. How do you see enterprises kind of balancing these different retrieval techniques? I mean, are there specific use cases where the hybrid approach is better? Are there, advantages in that versus vector alone? How are you seeing enterprises looking at this?
So this is kind of an interesting question because vector search is still new for a lot of enterprises. Now, even though you've been going since 2014 and some of the others have been looking at that, as we started doing things like TensorFlow and then PyTorch came along and some others, we were looking at how do we store persistent data and natural language processing and natural language understanding into a vector database and under putting those pieces together. So it came out was like, how do we even store this data? Where do we go with it? And most enterprises are still trying to figure out, do we need this? Where do we put it? Where do we put the data? How do we do it? What we've seen is then fast forward adopters, like companies that are really kind of AI and machine learning forward. Really, we're looking at, okay, I've got a model, I built it out. We're using, you know, any of the machine learning tools that we've been using for the last decade. Now, how do I store all of that information? How do I do my recommender engine so we can store things quickly? How do I do the embeddings and put all the pieces together? Those data scientists were kind of driving it forward, and then those companies were thinking about, okay, I'm only storing my vectors in here. What we're finding is as we're getting a little more mature, organizations are looking at, can I do kind of a hybrid approach to that? Can I store multiple things in a database? Sometimes yes, sometimes no. It depends on your environment. It depends on what you're trying to store and where do you go with that. One of the things that Vespa does really well is some of that hybrid search that you were just mentioning about, right? So you've got the lexical search. Can I search on particular words? Can I look at different kinds of matches that give me good information, that give me then an exploratory? In a database, traditional database, it's really difficult to do an exploratory search because if you don't know, it's not going to find it for you and it's just going to tell you a binary yes, no. What it lets you do is get close and you can start to go and you can look for terms and look for concepts. And this is what makes machine learning and some of the large language models so incredible is they allow you to do complex searches that with some of these hybrid terms so that now I can start to find things and tease out information and tease out relationships. Again, when we look at vectors, we talk about something called a vector space, which gets a little geeky at times. But when we pull that apart, we're looking at as we store information, like king and queen are going to be close terms, and cat and dog are going to be close terms, but those two things are going to be kind of far apart from each other because you don't normally associate them. Now, with our vector embeddings and some of those exploratory search components, I can now start to find those concepts faster, quicker, look at how we store information, and I can start to ask natural language queries instead of using traditional structured query language or SQL to be able to find things in a database that I didn't know, and get more information and get better pieces out. So this, is again kind of one of the great things about Vector's approach in terms of how you do hybrid search and retrieval and get more information out of there. So as organizations are looking at how do I get more out of my data and understand it more, really, companies like Vespa are really kind of riding that crest of, wow, there's lots of things that we can do with this and lots of information that we can pull apart.
Yeah, yeah. And I mean, as part of all of that data, obviously there's some scaling considerations there. Vespa can process hundreds of thousands of queries per second with very low latency. what are like what would you say are the key architectural or engineering differences that are the factors that are driving this level of scalability?
Sure. Well, this is really kind of neat. So as we were been researching Vespa and some of the different technologies, this is one of your differentiators. And we highlighted this in the Sonar, and we talk about the different ways that you can store data and indices and the metadata and the machine learning interfaces to be able to do this on the same machine and yet also have distributed deployments. So this is really amazing. So now you're keeping information close and allowing you to do that. And then as you scale, it now some of those components are able to say, okay, as I'm scaling, where's the data stored? How's it stored? And I can go across multiple machines to be able to do that. This is kind of building on the old Hadoop paradigm from years ago about being able to store it, scale it, putting it across multiple things. Because what you want to be able to do is as data gets bigger and bigger, especially for large organizations, you want to be able to scale that database out. And the problem with traditional databases is it's really hard to scale them across multiple machines. We've been really struggling with that until we started to come up with other ways to do it, and kind of it gives us a sense of efficiency. Like traditionally, I could have SQL Server database and I could scale it, but I had to make copies of it, put it across multiple things, and it got really big and really bloated, and it just made it really difficult. With some of these, you're taking kind of then that different approach because you're tightly integrating on the same nodes, and you're thinking about how do I grow and expand some of that raw data, the vector embeddings, all of those things really kind of help Vespa stand out in the field in terms of speed and efficiency, and how you're really not having to travel across the network to try to find things. You know where the data is stored on what particular machines, and you're able to do rapid retrieval and then scale it out and grow with minimal time because all that processing is done on the machine where the data sits. So it's a really incredible architecture, and it's been really impressive being able to kind of dig into that and understand how Vespa works.
Yeah, absolutely. And I mean, so you talked a little bit about how that works behind the scenes. So from a real world kind of performance scenario, could you give an example of where this would make a difference?
So, all right. So, case in point. So, I build a model, and I've been using. I've got a MacBook, and I can build models all day long, and I love it because I can run them locally. But if I wanted to then put that into production, then I've got to pick it up, put it into a container, put it up in the cloud, and off I go. I don't know that it's going to scale. It may run great locally, but as my database scales, as my information scales, as I do a lot of that. So what we're seeing is a lot of data scientists work the same way. They'll write things on the local machine, they'll test it, and they run it, and they try to scale it. If they don't have a scale distributed architecture, it falls flat, and then they find that out. So as their machine learning engineering teams are going and saying, let's test it, let's scale it, let's make sure it works, that model may work great locally, but it doesn't work across an enterprise. A lot of enterprises have that. So when they start to look at how do I differentiate in terms of scaling and how do I get my architecture and my enterprise to scale, now with a company like Vespa, I can look at multiple data centers, multiple data sets, looking at different information. And then with that centralized node, I can say, okay, when I ask a query, it's going to run it where the data sits, grow it, bring it back. And now I've got blazing fast speeds. Where that's important is most enterprises are usually running some kind of web app that they're looking at customers or users. And in this day and age, people don't have long attention spans, and they get frustrated if they don't have fast information retrieval. We're used to being able to go into Claude or ChatGPT or Gemini or any of the new models of the week and see almost instantaneous response. This distributed architecture that Vespa uses gets enterprises that same ability to be able to run the things that they're doing, be able to do a rapid response back to the consumer. It also allows them to scale. So when I look at rapid response, it may be one or two people who are getting really, really fast speed. But now I want to put in 10,000, 100,000 end users. Now I'm looking at how do I do that? How do I get that speed and efficiency out of that model right? So we've grown it from one box to now I'm across data centers, or I'm across, my hyperscalers as I'm building things out. Really kind of exciting that we can take these models and do amazing things with them and do them very, very quickly.
Yeah, yeah, absolutely. And just thinking through that example, I'm thinking about, working with massive amounts of data, but also massive amounts of users interacting with that data and wanting that timely response. And you want to be able to not just be quick with indexing and updating the data, but making sure that it's available and accessible quickly to those, whether you have hundreds, thousands, millions of users on your product.
Right. Again, scale is king in the era of cloud. And as your enterprise wants to grow and add more users, again, that's really kind of how they think about it. They're also looking at cost considerations. Remember, we were talking earlier in the radar. As I'm looking at scaling, am I going to see hockey stick growth of, oh my God, this is just eating up all of my budget? As a CTO, I'm looking at that. That's one of the key things I'm going to think about when I buy a product. In putting my CTO hat on and I'm looking at my budget, my engineers are just going to go do engineering things. And then I'm going to say, okay, that's really cool. How much is it going to cost me? So that's one of the things that we also saw very well out of Vespa is that as it scales, it stays consistent within a budget. And I know exactly how much it's going to cost me as I add new nodes, I add new features and functionality. And I can then, as I'm adding more users, I can then figure out what that scaling cost is going to be. And it's really reasonable, which is really kind of nice as I'm looking at all the other things in my fleet of stuff that I've got to think about. I'm now going, okay, I can rest easy at night because I know I'm not going to get some surprise bill and go, oh my gosh, I can't afford this anymore.
Right,
So,
right. Yeah.
another nice thing to think about. And again, this is what, so as we're looking at all of these different vector databases, this is why this is an important consideration for us too.
Yeah, yeah, absolutely. So I want to take a minute we've definitely seen these native vector databases gaining traction,
Mm-hmm.
but those traditional databases like Snowflake are also evolving because they want to compete in the Gen AI and RAG space as well.
Sure.
So given their limitations in areas like text and visual search, how do you see those traditional solutions evolving? And do you think they can realistically close that gap?
When I'm looking at enterprise scale and I'm looking at large volumes, where vector databases really shine versus traditional databases is we talked about, kind of these search engines that would say, okay, I've got a way to search either across rows, what we call a tuple in a database, or I can search, kind of down and do a columnar search. Okay, great. But again, I'm looking for an exact match. I'm looking at that binary tree kind of match going, okay, is this a yes or a no? The vector database, I don't have that. I can do more things. I can ask more questions. I can get deeper. With a company like Snowflake, Snowflake's got a great kind of database product. It's really designed for analytics. And because it was designed specifically for analytics, I don't see it like it's an add on to the functionality. And the guys I know some of the guys at Snowflake, and they're brilliant, brilliant engineers. They're going to do some amazing things and they're going to push that forward. And it's nice because all the other vendors are kind of pushing the technology forward as they're trying to figure out how do I add it in to my existing offering. I think for a while, I don't really see them disrupting the vector search space as much as I do companies like Vespa who are really driving the innovation there. I see them kind of following in your footsteps, taking what you're doing, trying to add that into their features and functionality. And again, it was designed for one thing. And if I'm doing a columnar search because I've got a great, product that's going to give me all of my analytics and give me good information, I'm now trying to cobble things together that aren't quite the same and don't function the same. So some of that architecture is going to be difficult to add into. I see if I'm looking at, okay, if I've got to go build out a product tomorrow and I've got machine learning and I've got analytics and the other things, I'm going to look at more of a hybrid approach. I want to have best in breed things to do what they do. I would definitely pick Snowflake for my analytics for my BI and all of my reports, all of those things where I'm kind of driving along the way. And then I would pick something like a Vespa for all of my natural language processing, all of my indexing, all of those things where I'm looking at storing all of my embeddings in there and being able to do a vector search through that information to be able to get me that data back. I see them as two different products doing two different things, and that's why sometimes it doesn't necessarily make sense. That's why I don't see Snowflake as much of a threat in this space yet. I don't see them because, again, the architectures are very different. And again, it's reflective in the Sonar as well why some of those add-on vendors are out in the challenger space, and then Vespa is really in that leader circle. I just don't see them as compatible things. It's again, you're adding different things to your you're trying to graft on something that it wasn't really built for, and you're trying to come up and add that feature in and say, well, we're a one-stop shop. Yes, but you're not as good as the ones that are purpose built, and that purpose built is going to make a huge difference in terms of the feature set you get, the speed, the adaptability. And again, I think they probably saw this at Yahoo when you were starting and you spun off. They realized we can't really store these two things together because they're not the same. And how we do them, if we try to put them under the same thing, it's not going to work. We need to move it out into its own thing to be able to do it in its own way. I really see that's kind of the future of of vector databases and why purpose built is always going to be so much better and so much faster.
Yeah, exciting time. Now, Whit, I really appreciate your time. We'll go ahead and wrap now, and I want to thank you again. We'll definitely be continuing to read your research, the sonar reports, the radar reports, and we'll be looking forward to seeing what you come up with next.
Great. Thanks, Bonnie. And we're absolutely looking forward to what you're coming up with next because, again, on the Sonar, we rated you as one of the fast movers there. So keep up the good work and thanks for having me on.
Awesome. Thank you so much.
You bet. Thank you, Bonnie.